Hi everyone. For this question, it said a tire company launched a new tire that have a lifespan distributed normal with mean 50,000 and standard deviation 5,000. So first we write out what is our X. It is a lifespan of the tire. So X is distributed normal with mean 50,000 and variance. So given here standard deviation, variance will be 5,000 squared. Then for the first question, they're asking find the probability of the tire lasting, means its lifespan not more than 60,000. So it will be less than equal 60,000. So for this question, our X is starting from normal distribution. What we're going to do next, we are going to change it to z-score. Then we draw our normal curve to find from table so that we can get answer. So for X, to change to z-score, we will need minus mean over standard deviation. So our z is less than 2. Then we're going to draw our normal graph where 2 is positive value at right hand side. Less than means we want this region. In order to get this region, we're going to read table. Our table is right tail table. So to get this region, we're going to take the whole region here, which is equals to 1, probability equals to 1, minus the right tail, which is z more than 2. So we read our table, value of 2, probability is 0.0228. So here we have 0.9772. Next, we move on to question B. So for here they say if the lifespan of 50% of the tire is between alpha and beta km, find the value of alpha beta which are symmetrical at mean. So from here it will mean that 50% we change it to probability of the lifespan x in between alpha and beta is 0.5. So 50% change to probability, it will be 0.5. Then from here we need to find what is our alpha beta. Given the hints here, they are symmetrical at the mean. So we notice here our x is still talking about lifespan where x is distributed normal 50,000, variance 5,000 squared. So in this kind of situation, we are starting our questions by answering in the status of normal. Then we change it to z-score. Then we draw and we find out the table for the answer. So to change to z-score, alpha we're going to minus 50,000 over standard deviation 5,000. Then x we changed it to z-score. Then beta minus 50,000 over standard deviation 5,000, which is 0.5. So let us denote this to be A. So it says alpha and beta is symmetrical at the mean. So if I want to draw this region, it means that this is symmetrical around the mean. Mean will be in the middle here. So it will be symmetrical, a value unknown here. I put A and a positive value A. So the negative value will be alpha this side, positive value will be this beta value. So in between these two, it gives us 0.5. So from table, in order to get this area 0.5, we need to calculate that 1 minus the right tail table of A, which is 1 is positive tail, 1 is negative tail. So we need to minus 2 right tail table, which is equals to 0.5. So we simplify this, where our right tail table reading will give you 0.25. So from here, we're going to find out what reading then can give us probability 0.25. So we are going to refer to the last pages here where the probability is given 0.25 with the z-score here is 6745. So our A will be 0.6745, which means that one is negative 0.6745 and another one is positive 0.6745. So for alpha minus 50,000 over 5,000, here will be the negative value. For beta, which minus 50,000 over standard deviation 5,000, it will be positive value. So we're going to simplify this to find out what is the alpha. So alpha, it will give us 46627.5. Meanwhile, beta, it gives us 53372.5 km. Then next, for this question, we still discussing our lifespan of the tyre, so we still maintain this distribution. For this question, they say the company promised to replace any tyre that less than gamma. Calculate the value of the gamma if company promised to replace 1% of the tyre that are sold. Hence, if 30 tyre are replaced, what is the total number that the tyre sold? So first we need to find out what is the gamma. Here they say if your lifetime probability x less than gamma, so you are going to replace just 1% of it, so it will be 0.01. So from the statement here, we know that this x is starting from distribution normal. What we need to do is change to standard normal. Then we draw the curve to find from table to get answer. So to change to z, so gamma we need to minus 50,000 over standard deviation 5,000 to get 0.01. So let us express this alpha minus 50,000 over 5,000 as A. When we represent it with A, it will be easier for us in writing. So we need to guess whether this A is negative or positive. If this A is negative, less than it as much as the probability 0.01, look like this drawing is logic with the numbers of probability given here. If you put at right hand side, you less than that, seems like our region have to be more than half. So it should be probability more than 0.5. So we guess that this unknown A is negative. So to get from the table means we're going to read out the tail side. So reading the tail where z greater than A will give us 0.01. So by referring to the table 0.01, it will give us the z-score as 2.3263. So A will be 2.3263. So in negative because the z-score here at left hand side. So we substitute the symbol here, symbol A with gamma minus 50,000 over 5,000 so that we can find out the lifespan of the gamma. So here we have 38368.5. So after we finding the gamma here, they say it already having 30 tyre that are replaced. We need to find the number tyre that this is sold. So in this case means the probability of replace here is equal to 0.01 and the number of tyre replaced given here is 30. So they want to find out the number of sample space, which is the total tyre that are sold. So by using the basic of probability of the event replaced will be equal to the number of replaced over the number of sample space. So 0.01 equals to 30 over number of sample space. So we can know what is the total of tyre sold, which is 3,000. Next, for this question, it says if the lifespan of the Goodwill tyre will be distributed mean 60,000 and standard deviation of 81,000. So X represent our lifespan, now distributed normal with new mean 60,000 and standard deviation 81,000. So in distribution we need variance, so 81,000 squared. The first question, is it logical that the producer claimed that the tire can be used more than 85,000? Clarify your answer. So we need to find out what's the probability for this situation to occur. Then only we can claim that it is logic to having that statement. So first we need to find the probability of this lifespan which is more than 85,000. So given here X is start from normal, so what we need to do next will be change to standard normal, finding the Z score, drawing the normal graph and find from table to get answer. So when we changing to Z, this 85,000 need to minus 60,000 over standard deviation which is 81,000. So it gives us a Z score 0.31. We need 2 decimal only. So for this probability more than 0.31, when we draw out the normal graph, so it will be at this side. So to read table, we just read straight away more than 0.31. So 0.31, it will give us 0.3783. So in this situation, we can notice that our probability just 0.3783. So if the producer want to claim that the tire can be used more than 85,000, in the reality we can see here the chances only 37%. So it will eat logic to claim that. So for here we will say it will be no. So for us we will say it will be no logic because this situation gives us less than 50% of the tire can be used more than 85,000 km. From our probability, we only can know that the tire that can use more than 85,000 only is 37.83 only. So means we only have very low chances of the tire that can be sustained until 85,000. So when this producer want to claim that the tire is long lasting, can survive until 85,000, from the calculation here you will see that the data here will not enough to support this statement. So next for question 2, what is the percentage of the tire will be replaced in the warranty period that are used at least 45,000? So for the tire that can use at least 45,000, we see how many percentage, so it will be the percentage to be replaced. So we start with the distribution X, which is start from normal, so we change it to Z. Later we're going to draw and then to find from the table to get answer. So to get it to Z, 45,000 will need to minus 60,000 over 81,000 standard deviation. So the Z value will be more than negative 0.19. So make sure our Z score just 2 decimal only. Then we draw out negative 0.19 more than that. So which is this area. So as we read the table, we only have tail part. So to get that region, it will be 1 minus the right tail of 0.19. So to read the table, 0.19, it gives you 4247. So we can get the probability as much as 5753. So therefore, the percentage will be equal to 0.5753 times with 100%. So that we can know that 57.53% will be going to replace in the warranty period. So that's all for this. Thanks for watching.